In section 12, we're going to install the engine, the torque link, and the clutch assembly. Now, what's important before you start the installation of the engine, you have to have the main rotor system and the secondary final installed. The height of the engine is controlled by the secondary, so it must be final installed. So let's get started.
Refer to the Construction Manual, Section 12, for components and prints. This is the A600 supercharged engine as received from Rotorway. Before beginning any work with the engine, make sure the exhaust portholes have been taped or have plastic plugs. If this is not done, a washer or another object might accidentally drop into the exhaust port and would run the risk of damaging a valve the first time the engine is started. The tail boom support brace tubes can be removed for easier access to the engine mount area. However, if this is done, be sure to remove the tail boom completely or support the tail boom from above or below before removing the support tubes, or damage to the airframe will result. Locate these parts for the upper engine mount cup. The rivets and washers are located on E24 Card 1. Check the fit of the upper engine mount cup in the clevis. Remove any burrs that interfere with the fit. Fit and cut the rubber strip so it covers the machined area on the inside of the cup. Drill 2 1/8-inch holes equally spaced in the cup. Then drill through the rubber. Clean the surfaces with acetone and glue the rubber to the cup with 3M structural 2-part epoxy and rivet in place. Use the supplied washers on both pop rivets. Clamp inlet set for the cure period about 12 hours. At this time, the spark plugs can be gapped and installed. The plug gap specification is found in the engine manual. Use a gap tool to check and set the spark plugs. Place a small amount of anti-seize on the threads of the spark plugs. Do not use too much so that it could contaminate the electrode. Remove the plugs from the spark plug holes and install the plugs. The spark plugs are torqued to 10 foot-pounds. Remove one of the male rod ends from the E27 card, part number E27-1160, and check the fit of the ball into the clevis as shown. Deburr the clevis to improve the fit. This should be a snug fit. Locate E00-4501 12-point bolt on E24 card 1 and remove from the card. Apply a small amount of anti-seize to the bolt hole and thread each exhaust port hole with the bolt to check the fit. If you have a supercharged engine, you will notice the ACES belt is not tensioned for shipment. Set the proper belt tension before installing in the airframe. The belt should have a 1/8-inch deflection with a 10-pound push. To do this, adjust this idler to lightly make contact with the belt. Adjust the inboard idler so the belt tension deflects 1/8 of an inch with a 10-pound push. On the engine pulley, note that the distance from the top of the uppermost groove to the top surface is 200 thousandths of an inch greater than that of the secondary pulley. It's important to note that if the engine was adjusted and installed with the top of the engine pulley at the same height as the secondary pulley, the main drive belts would be 200 thousandths of an inch lower at the engine pulley. To maintain correct engine height for the proper belt alignment, place a piece of masking tape on the engine pulley as shown and mark a reference line 200 thousandths of an inch below the top edge of the pulley. Fabricate an engine lift to aid with installation. An ATV lift works well for this application. Use blocks of wood to raise the lift platform to standing height of approximately 22 inches. Cut the top block to allow access to the bolt holes in the lower mount ring. Always use 1 to 2 extra people when moving and lifting the engine into the airframe. Any fall from this height could cause serious damage to the engine. Make sure when the upper engine clevis was installed in Section 8, an 1/8 inch gap was maintained between the upper engine clevis and the bottom of the square drive tube. Install the all-thread 5/16 inch bolt, part number E00-2525, and its jam nut, with a small amount of anti-seize on the threads. Remove the tail boom support tubes. Be sure the tail boom is supported. Reverse the 3/8 inch bolts as shown for ease of installation later. With the engine on the floor, check the fit and install the lower mount and rubber ring. Place the upper engine mount cup in the main drive pulley. Be sure the bolt access notch is facing forward. With the help of someone, place the engine on the lift. Move the engine into position with a combination of forward movements and lifting. As the lift rises, carefully move the engine into position, up and over the lower engine mount arms. Allow the main drive belt to slide past the drive pulley. Align the ears on the upper engine mount cup to fit in the clevis. Install the bolts that secure the lower mount ring to the engine mount. You may need a pointed bolt to help align some of the holes. Reinstall the tail boom support tubes and remove your temporary tail boom support. Install the long 5/16 inch bolts, part number E00-2524, with fender washers and nuts. Do not tighten these bolts at this time. Place the digital protractor on the secondary pulley and shim under the skids to set the secondary level fore and aft and laterally. Place the protractor on the engine flywheel to check the fore and aft level. Move the top or bottom of the engine within its elongated slots until the engine is level. Now with the engine level, check the alignment of the secondary pulley and the engine pulley. The straight edge should make contact with both sides of the secondary pulley and align with the mark on the masking tape that is 200 thousandths of an inch from the top of the engine pulley. Use shims on the lower engine mount to achieve the proper alignment by either raising or lowering the engine. Use ratchet straps to hold the engine in the airframe when adding or removing shims. Use care when securing the straps. The Y-shaped shims are used to lower the engine, while the round shims are used to raise the engine height. Use the template to make Y-shaped shims and use the rubber ring as a template to make the round shims. Hole saws work best to cut the round shims. Use no more than 3/8 inches of round shims under the rubber ring. If more than 3/8 inches is required, contact Rotorway customer service. It's also possible to use round shims above the rubber ring to help keep more of the rubber ring in the weldment, as shown here. The inside diameter of the above rubber ring shims should be about 3 inches. When the engine height is set, the engine should be as far aft as possible and level. Check on the pilot side to see that the valve cover drain does not hit the tail boom support tubes in this location shown here. Minimum clearance should be approximately 1/2 inch. Parts for the torque link. Tap the arm of the torque link with a 5/16 of an inch by 24 threads per inch tap and assemble as shown on print E27-2000. Cut the material and make 2 washers. Fit the torque link by grinding off the top and/or bottom as necessary for alignment. Note, the aluminum insert is 1 1/8 of an inch tall. The overheight of the torque link tube should just be slightly less than that. Install the torque link with the supplied hardware. It's sometimes necessary to bend the link arm up slightly for a better fit. When the engine is at the rear of the slots in the mounts, the rod end should not be screwed all the way into the torque link arm. Leave enough thread in the rod end for future adjustment. Here are exploded views of the idler and pulley assembly. One of the 1/2 inch washers supplied with the idler arm is chamfered on the inside diameter to clear the radius on the idler arm spindle. Install this chamfered washer first. Additional washers may be added after this one to adjust pulley height and clearance. Check the gap between the idler arm and the rim of the pulley. Ensure there is at least 25 thousandths of an inch clearance. Install extra washers and secure the nut to the pulley. Do not tighten more than 12 foot-pounds. Here is an exploded view of the hydraulic clutch tube assembly. Install the seal into the cylinder end plug, followed by the aluminum flat washer and snap ring. Make sure the edge of the seal with the lip faces out toward the washer. Install the clutch tube piston on the piston rod. Assemble with a 1/4 inch by 5/8 inch all-thread bolt and a 1/4 inch washer using Loctite 242 thread locker on all threads of the bolt. Install the O-rings on the piston, cylinder end plug, and piston rod. Use engine oil as an assembly lubricant. Make sure the clutch tube weldment is clean and oil the inside so that the clutch tube piston will slide freely. Install the parts into the clutch tube weldment. The cylinder end plug has 2 threaded holes for the hose fittings. The angled hole should be towards the front of the ship when the assembly is installed. Note: the red silicone O-ring is a travel indicator. It will move on the shaft during operation. Install the 4 832 socket head cap screws using Loctite 242 on the threads. Then safety wire the screws to each other as shown. Shorten 2 5/16" male rod ends so the threaded shank is 1 inch long on each. The threaded part of the rod end must not limit the cylinder from completely closing. The top rod end on the passenger side must be turned in until about 2 threads show past the lock nut. Coat the threads with a sealant such as Loctite PST or Permatex high temp thread sealant. Note: on some clutch tube assemblies, this hole may be a blind hole. If that is the case, then the rod does not need to shorten and no sealant is required. Use the shortened rod end on the lower support tube and install with 2 threads showing past the jam nut. Using a square against the top of the cylinder, check that both ends are positioned to form a 90-degree angle. Turn the lower rod end in or out until a 90-degree angle is achieved. Note: this angle should remain the same on your final installation. Check the fit of the clutch tube weldment for pulley clearance. Minimum clearance is 25 thousandths of an inch. Measure the distance between the tabs for the idler arm mount. Use that measurement to trim the inner pivot spacer for a snug fit. Caution: the inner pivot spacer is a precision fit. Use care not to mar the surface or distort this spacer when trimming to fit. The idler arm bushings will need to be trimmed to fit with the airframe mount tabs. At this time only, install the lower nylotron bushing in the idler arm. To help determine the height and alignment of the pulley, place a piece of 1 inch by 26-inch square tube on top of the secondary. Use bar clamps to hold in place. The use of the 1 inch by 26-inch square tube helps with the position and alignment. Use shims between the square tube and the secondary to adjust the height as necessary. Now clamp the idler arm to the square tube. The correct idler pulley height will be centered on the secondary. Shim the 1 inch by 26-inch tube up from the secondary as necessary. Now place the clutch tube weldment in position. Make sure there is adequate clearance between the top of the tube and the airframe before trimming the idler arm bushings. With the idler arm in position, determine the amount to trim for a snug fit. Trim or grind off the top and/or bottom of the bushings. The ends must be ground squarely or be 90 degrees to the hole. After grinding, the bushings must fit snug in the airframe bracket without any end play. When the correct fit is achieved, trim the nylotron bushings so the total length is about 5 thousandths of an inch less than the length of the inner steel pivot spacer. Verify the pivot point on the idler arm bushing and drill a 5/16 inch hole in the top ear of the bracket only. Note: it may be necessary to radius the idler arm for clearance of the airframe when pivoting. Use a pointed bolt to align the hole in the ear and the steel pivot bushing. Clamp the idler arm in position. With the airframe level, check the bottom side of the pulley to verify its level fore, aft, and laterally. Adjust the arm as necessary. Use a 5/16 inch drill bit and carefully insert it into the top ear hole and through the pivot bushing. Drill just enough to make a center point and then remove the drill. Move the idler arm out and use a small bit to drill the hole. Open the final hole to 5/16 inch drill to burr the hole. Use Loctite 242 on the 1/2 inch lock nut and be sure to torque to 12 foot-pounds only. Grease the mating parts and the bolt. Install the bolt from the top and torque the bolt to 12 foot-pounds. Your final installation should have the idler pulley centered on the secondary and be parallel with the secondary fore, aft, and laterally. Install the clutch tube on the idler arm. On your final install, use Loctite 242 on the threads of the bolts and torque to 12 foot-pounds. Check the clearance between the bottom of the airframe square tube and the cylinder. On the pilot side, use fender washers to fill the space above and/or below the rod end. There should not be any upward or downward pressure on the rod end. Set the hydraulic cylinder fully extended. There should be a minimum 1/8 inch clearance between the pulley and the frame on the passenger side. This can be adjusted with the rod end on the end of the piston rod. Using a spring scale, pull 7 pounds on one main drive belt. The belt should move 5/8 inches to 3/4 inches. To change the tension of the main drive belts, move the engine. The top and bottom engine mounts are slotted for this reason. The secondary pulley and the engine flywheel must remain parallel and the same height. This is a layout of the clutch parts and hoses. Use a high-temperature thread sealant on all pipe thread fittings. Install the pressure regulator assembly on the seat back between the pilot and passenger seats. Measure 6 inches from the top of the center collective tube. The collective must be in the down position. 6 inches is the point for the bottom 832 screw hole. Use the finished trim plate as a guide for locating the holes. Install the regulator to the seat back. If fiberglass is thin, reinforce it by fabricating a 2-inch by 3-inch piece of 50 thousandths aluminum backing plate. Route the two 3/16-inch hoses, part number E28-8300, from the brass T on top of the pressure regulator to the top of each cylinder head. Remove the valve covers. Remove the 3/8-inch aluminum plugs above the valve covers. Install the 3/8-inch reducers, A24-4420, and return fittings, A24-4400. Use Teflon tape on the threads and direct the hose barbs towards the front of the ship, angled slightly outward. Make sure hoses are routed away from the exhaust. Trim hoses to length as needed. Install the hose, part number E28-8310, from the bottom aft fitting of the regulator to the oil pressure gauge. This gauge can be permanently mounted in the ship at the pilot's foot pedals or used for setup, then removed. A plug is supplied in the kit for gauge and hose removal. Locate and install the oil filter mount located on E28 card 2 with two 5/16-inch bolts. The oil filter mount should be in line vertically with the engine as shown here. Tap the fittings and install the oil filter to keep from getting any dirt in the oil system. Install the brass T fitting into the hose fitting on the filter mount. Route the hose, part number E28-8320, to the front fitting on the bottom side of the pressure regulator assembly. Note: the oil pressure sensor will be installed later in section 21. Route the 1/4-inch hose, part number E28-8330, from the passenger side of the clutch tube cylinder to the forward fitting on top of the pressure regulator. Tie the line to the square drive tube away from moving parts. Note: this line must be installed loose enough to follow the cylinder through its full travel. Route the 1/4-inch hose, part number E28-8340, from the pilot side of the clutch tube cylinder, the forward hole, to the lower rear T-fitting on the pressure regulator. Tie the hose to the square tube on the left side of the main shaft. Both cylinder hoses must not bind or pull tight throughout the full travel of the cylinder. Install the hose, part number E28-8350, from the elbow on the pilot side of the clutch tube cylinder to the elbow on the tensioner. This connection will be used to bleed the air out of the system at startup. Note: the cog belt tensioner will be installed later in section 15.